Here we have a problem on evaluating limits. Okay, so what I'm going to do in the first step is I'm going to directly substitute the given limit for x. That is, I'm going to plug in pi for x into the given function. Okay, let me do it. Then I'm getting cosine pi positive sine of 2 times pi positive 1 over pi square negative pi square. Okay, from the unit circle, we know that the value of cosine pi is just negative 1 and the value of sine 2 pi is 0, positive 1 over. So when I simplify pi square negative pi square, it becomes 0, and in denominator, so it's 0. So when I combine negative 1 and positive 1, it becomes 0. So I'm getting 0 over 0, so which is called indeterminate form. Okay, whenever I evaluate a particular limit, if I get indeterminate form as a result, that is 0 over 0, it should not be considered as a final answer. And what we need to do is we should try to simplify the given function if possible. Otherwise, what I need to do is I have to use L'Hopital's rule. Okay, what is L'Hopital's rule? So in the given, I have to consider the step which we have right before where we have applied the limit. Actually, this is a step I have applied the given limit pi for x. You just consider the previous step. That's nothing but the given question. So in the given question, I have to find the derivative of this numerator and denominator separately. Usually when I find derivative of a particular function which contains variable in both numerator and denominator, I'll be using quotient rule. But when I use L'Hopital's rule, I should not use quotient rule. I have to find the derivative of the numerator and denominator separately. So for that, I have to consider the step which comes right before where I have applied the limit. So this is the step I have applied the limit. So consider this step. So in this step, I have to use L'Hopital's rule. So by L'Hopital's rule, let me finish writing. So L'Hopital's rule, by using L'Hopital's rule, we get limit extends to pi. So I have to find the derivative of this numerator. So the derivative of cosine x is negative sine x, positive. So the derivative of this sine 2x is cosine of 2x. By chain rule, if I do further derivative for this 2x, it will be 2. So cosine 2x times 2. And the derivative of this 1 is 0. I don't have to write that one. And here the derivative of this x square with respect to x is just 2x, and this derivative of this pi square will become 0. Okay, now what I can do is I can plug in the limit. And also before we apply the limit, if there is any possible simplification, we have to do it. I don't think there is any possible simplification in the function over here. So now what we can do is we can apply the given limit for x. That is, we have to plug in x equals to pi into the function over here. So when I do so, negative sine pi positive cosine of 2 pi times 2 over 2 times pi. Okay, we know that from unit circle the value of sine pi is 0, so it's 0, and the value of cosine 2 pi is just 1, so 1 times 2 over 2 pi. So here 0 positive 1 times 2 is just 2 and over 2 pi, so this 2 will cancel out. I'm getting 1 over pi. So the evaluation of the given limit is 1 over pi.